Hello, everyone, and welcome to the Open Systems Media and Embedded Computing Design Roundtable Discussion and Presentation. Hardware Accelerated Trust, FPGA-Based Secure Networking at 100 Gbps, sponsored by Pantherun. I'm Ken Briota, Editor-in-Chief for Embedded Computing Design, and I'll be your host and moderator for today. If you're not familiar with us, please visit embeddedcomputing.com, where you'll find our coverage of everything related to the design of hardware and software for embedded systems. We are chock full of design articles, white papers, blogs, videos, podcasts, and lots more. And we're always adding new content and technology coverage. In today's session, we're going to be looking at how FPGA-enabled platforms are becoming foundational to secure, scalable, and future-ready networking infrastructure, where performance and security can no longer be treated as separate design goals. Our speakers and panelists today are Srinivas Shekhar, co-founder and CEO of Pantherun, and Rohith Gopalakrishna, country manager for the embedded group at AMD. Before we get started, I just have a few housekeeping items to go over here. The entire discussion will likely take around 55 minutes. That'll give us some time to answer your questions throughout the discussion. We plan to get to as many as time permits, so please submit them whenever you think of them as we go along. You'll find on the right side of your console window an area where you can enter your questions in real time. We'll be keeping an eye out for your submitted questions and comments, and we will address them in context as we go along, as many as we can before we get to the end of time. If we don't get to your question before we run out of time, someone from Pantherun will get back to you with an answer as soon as they can. If you have a technical difficulty or a question pertaining to the webinar itself, for instance, your slides aren't advancing or you're having some trouble with your audio, please put that into the question box, and one of our technicians will respond as soon as they can with a fix. On the left side of your screen, you're going to find our speakers' full bios. There's also a clickable tab there that says Handouts. That's where you can find and download the slides that are going to be presented today, and you'll also find some other material there in which you might be interested. The on-demand version of this webcast will be available about 24 hours after we sign off today. So if you missed something, or you want to go back and review, or even share this discussion with a colleague or a friend, you can find it again through the same link that you used to sign in today. A quick reminder that all Open Systems Media and Embedded Computing Design webcasts are copyrighted and may not be recorded without prior permission. One last note. Please check out our weekly news show in case you missed it, in which we round up some of the biggest embedded news stories every Friday on YouTube, and its accompanying LinkedIn newsletter that comes out every Monday. Make sure you subscribe to both so you don't miss any embedded technology news. I think that's enough for me for now. You're here to hear from our speakers and for our discussion, so I suppose we should get us started. Rohith, I'm going to hand the virtual microphone off to you. The floor is yours.
Thank you so much, Ken. And welcome everybody. My name is Rohith. I am the country sales manager for the embedded group in AMD India. Today my session is going to be about the hardware accelerated trust. But before I get into the topic, I would like to give a brief about who is AMD and what we do. So let me just quickly take you over the slides about AMD, right? So who is AMD? Right. So AMD is the high performance and adaptive computing leader. We're focused on creating solutions for the world's most important challenges. So basically, we are focused on high performance and adaptive computing. That's the group I belong to. Within the overall AMD umbrella, we have multiple business units. The biggest one is the data center, of course. Followed by that, we have client and gaming business unit. And the third one is what we call as the embedded business unit, which includes the leadership FPGAs, SoCs, GPUs, embedded CPUs, embedded GPUs, and a broad set of other accelerated cards. This is the unit I belong to, and I'm going to share more details about this business unit. Now, when you look at this this product line itself, we serve a very broad and very diverse market. We have some of them shown here. It ranges from automotive to aerospace and defense, storage, communication, industrial, healthcare, test and measurement, and emulation, which is a very important segment right now, considering the semiconductor shortages and the whole AI boom that you're seeing. Followed by that, we have the Pro AV broadcast, gaming, and consumer, right? So very diverse set of products, segments, where AMD is quite relevant. If I double click on few of them, to start with, if you look at aerospace and defense itself is a very broad market. There are so many different end applications within that, which of course require a lot of security and safety. If you see from the bottom left, we have the Milcom and public safety radios. These are software-defined radios. We have avionics systems. We have ISR systems. We are very strong in the space Milcom and SATCOM application in the space domain. One of the things that is also gaining a lot of traction right now is the electronic warfare. Due to the current geopolitical situation, missiles and munitions, and all of these subsystems have an underlying security solution that is built in based on some of the pillars of our AMD security philosophy, which I'm going to take you through in the upcoming slides. Now, shifting gear from aerospace and defense, if you look at our industrial portfolio, we are present in several diverse industrial applications, starting from robotics, motor drives, PLCs, different types of IO modules and panels. Railways, very interesting and very important segment for us. I think you will hear more from Srini when he is presenting his slide deck also. Smart city, anything related with machine vision. I don't know if some of you have also been exposed to the Kriya modules from AMD, very well fitting to the machine vision application. Smart grid, and nowadays we are also seeing a lot of data center power infrastructure where we are seeing a lot of AMD being used. And then finally, additive manufacturing, and 3D printers. These are some of the industrial applications where AMD has relevance. If you dig deeper, again, I'm taking a liberty to talk a little bit more about railways. Railway is a very complex and very high demanding segment with a lot of safety and security features added into it. What you see here is a pictorial depiction of a railway system. Look at the number of different subsystems or electronic systems that go into a railway system. Starting from the front, you have lidars, cameras, vigilance monitoring system, event recorders. As you go along, you are getting into a lot of motion specific application. It can be brake control, interlocking system, traction control system, and then you have security related systems like cameras or passenger counting kind of a application. Followed by that, you have train networking itself, which again is a big subject in itself. Requires a lot of managed Ethernet switching and also requires a lot of security built into it. This is a classic example of why hardware accelerated trust is very important in a very low latency application that requires demanding high performance hardware. Moving on from railways, if you look at telecom infrastructure, we are present all the way from radio to the cloud. You can look at any 5G radio today, and probably we are also getting into the 6G domain right now. Right from the RU, the DU, which is the base station, the CU, core network, and the data center, right? All through, you will see networking being the centerpiece of or the fundamental foundation of all these applications. And majority of these infrastructure is currently talking at least 25 gigabits per second, going towards 100 gigabits, 400 gigabits, and some of the cases in core network and data center even going up to 800 gigabits. So when you are looking at this kind of data rate, it's very important to have a secure networking support. And that's where we get into our technology like transceivers and secure features that are built into the device itself. And last but not least, we also have the networking, which is the wired networking applications like switches, routers, firewalls. These are all, again, very high throughput, very high bandwidth, low latency application, which requires security features built hardwired into the device itself. And that's where the technology of having built-in security features that we have in AMD is very relevant. Automotive, again, another demanding application with extremely low latency. We have in-vehicle networking, which is reaching probably to terabits per second right now with some of the high-end vehicles. Again, it requires hack-proof links inside the car itself, and also the car that is transmitting to the external world. This is another area where you see a lot of secure networking application that are required. And finally, robotics, right? Robotics is probably getting so much traction, globally. But think of robotic application, or think of a complete factory, where robots get hacked, right? It's extremely dangerous. And that's where we make sure that all the secure features and secure solutions that are built within the silicon, and also through our partners like Pantherun, helps to make sure that these robots are safe and the factories are safe, and it's regulated. Now, all these applications that you saw, right from aerospace and defense, to railways, to robotics, to networking, these also require many times a long life cycle. So longevity becomes a very important factor within these kind of products. So AMD takes its device longevity very seriously. We have products that we have been shipping all the way since 2010, even before that right now, which are quite active even now, ranging from Spartan 6 to Arctic series, the Ultra Scale Plus, and now the Versal. We are pushing boundaries. We are really pushing all the way up to 2045 right now with many of our latest products that are there in terms of the life cycle support. Now, switching gear into the topic itself, which is the hardware accelerated trust, I just want you to understand why the software security actually hits a wall at 100 gigabits per second, right? In this topic, we are talking about how do we ensure that we are providing a safe and secure networking support at 100 gigabits per second. When you look at the traditional architecture like CPUs, it actually bandwidth limit us at 100 gigabits per second, right? It adds a lot of latency, jitter, and also it increases the attack surface when you use applications with CPUs, right? And this is exactly where the hardware, or the programmable hardware, comes into picture. You can run layer 2, layer 3 networking security. You can run a lot of custom encryption, and you also have a lot of built-in encryption features in these FPGAs and SoCs. More than that, there is nothing that will provide a deterministic response like a parallel compute architecture like FPGA, right? So combination of this is what we get: ultra low latency, deterministic throughput, with much reduced attack surface because it is hardware supported, not software centric, and also it is scalable because of our transceiver technology that is going from 10 gigabits transceiver, or our GTHs to GTYs to GTMs. We are consistently growing our transceiver throughput, which is helping us in growing the overall performance of the system itself. When you look at AMD, we are built on 5 different philosophies in terms of security, right? So the 5 security philosophy that we are looking at are information assurance. We have the cyber security features, anti-tamper, IP protection, and the supply chain assurance. These 5 are fundamental to any semiconductor chip that you look at. And I'll take you through some of these in a little bit more detail. But if you generally look at this, these are all meant for making sure that you have the hardware root of trust. That means you can trust the chip at the time of boot. You can trust the information that is fed into it, whether it's a bit file or it's a program. You can ensure that the IPs that you are putting onto it, it can be your custom IPs, it can be third-party IPs. Those are protected from any reverse engineering. You can also ensure that these devices come Trojan-free. That's where the supply chain assurance come into picture. And these are tested, and there is no counterfeit that is happening within the overall supply chain, right? So these are some of the features on which the AMD security philosophy itself is built on. If we just go a couple of them, if we double click on a couple of them, if you look at the information assurance, we have several cryptographic features that are built into the device itself at the silicon level. But on top of it, we also have several design philosophies like IDF, the isolation design flow. This is one of the fundamental security feature that we have, where you can physically, within the device, physically isolate different sections of your design from talking to each other, making sure that there is no overlap of data. That way, you know that you are controlling the islands securely. We do have a security lounge, which you can access through a login, where we have more details about how do you access the isolation design flow features and what are the methodology documents that are available along with this. When you look at anti-tamper, these are some of the features that I would like to highlight on. Uh, it's a very busy slide, but when you look at all the features that are listed on the left side, and you have the comparison of different families of devices that are listed on the right side, starting all the way from our 65 nanometer to the latest 16 nanometer MPSoC. I have not taken Versal here, but Versal has a lot more features added on top of this. But look at the number of built-in silicon security features that are available even on our 16 nanometer. These are the ones that are actually helping us to making sure that the device is quite secure at the hardware level and not just relying on the software level security. We also have white papers, a lot of white papers, and also AMD has a group called XSWG, Xilinx Security Working Group. This is a group through a lounge access. We do conduct XSWG workshops across the globe every year. The 2025 workshop was extremely successful, and we are going to have the 2026 workshops during August and September timeframe. Do look at the AMD events page for the workshop details, and we have a lot of such white papers and presentations happening in these working group sessions. Trust is another important factor. When you look at trust, what are you looking at, right? What do you care about? You do care about whether the device itself is genuine. Have I got the device at in the right way? Is there any malware or a Trojan that has been added onto the device before it has been shipped to you? These are extremely important ones, especially during the current geopolitical situation. It's extremely important to make sure that you're getting the device from the right supply chain. To facilitate this, if you look at the images on the bottom right, you will see small QR codes etched on top of each of our devices starting from 28 nanometer. Now, these are called device DNAs. We do have AMD app on Android and iOS where you can scan the QR code and actually read the device DNA itself to make sure that these devices are shipped through a legitimate mean. It is coming from AMD directly, and it will also provide you the details like the date code, lot code, and things like that. So these are some of the measures that we have taken to ensure the trust is kept. It goes even deeper. We start the trust all the way from silicon development, uh, through the supply chain, through the FPGA design, like how do I ensure the bit stream is safe, how do I ensure the hardware root of trust is there, all the way to the fielded system where you provide not just the silicon level security, but also the IP level security and then the third party IP level security on top of it. On top of this, when the device itself is running on the runtime, you do require a lot of security on top of the device. Now that can include secure system boot for the ROM code, even the bootloader and the OS image. And during the runtime, you require a lot of protection for the real-time application, or even things like protecting your own IPs interacting with each other, like the isolation design flow that I mentioned. So we do have several security features that are built on top of the silicon security itself. Now, what are the additional IPs that AMD provides on top of the security features that we have given, which is enabling like partners like Pantherun to build on top to build a very secure product, right? Now these can include things like 400 gig high-speed crypto engine, which is built into our Versal chipsets. It can also include ZIL secure libraries, which are IP libraries available for security. It can include the post-quantum cryptography hardware blocks that are built into our latest devices like Spartan UltraScale Plus, or it can be the soft IP like MaxSec, which is available as part of the Vivado IP catalog. So variety of applications that are built in, and variety of IPs that are available on top of the silicon security features to make sure that you're building the most secure system possible. Now, when I'm doing all these things, I also need to keep in mind that the bandwidth will get limited. There is always going to be a bottleneck for the throughput of the system, and that is exactly where AMD has a phenomenally good FPGA transceiver technology, which starts from 10 gigabits to 25, 100, 400. We are getting into 800 gig applications now, but our latest Versal family of devices actually provides 112 gig PAM4 SerDes performance per lane, which really helps in ensuring high speed and flexibility without compromising on the reliability. Now, the proof point, right? These are not just the slides and white papers. We have also got validated confirmation from NIST. Some of these algorithms that are listed here are all validated as per the NIST standard by AMD, and we are also currently shipping the post-quantum cryptography, the PQC feature-enabled chips called Spartan UltraScale Plus to customers. And on top of it, the third-party validation is what basically makes our solutions very credible. Now, this is the device I was referring to. This is our latest and greatest, which is the Spartan UltraScale Plus 16 nanometer device, which comes with a bundle of security features. And on top of the existing security features that we have also built in the post-quantum cryptography hard block that is supported, that is actually approved by the NIST. And we have several algorithms that are actually running on this right now. And we have systems that are being built, whether it is for data center, whether it is for scale up, scale out networking infrastructure. We are seeing a lot of customers showing interest in the cryptographic, post-quantum cryptographic NIC solutions, right? So these are some of the solutions that AMD has. With that, I'll end my slide. Thank you so much for listening. I'll be available for any questions post the second presenter's slides. Thank you, and back to you, Ken, to take it forward.
All right, and I'm going to hand it immediately right off to you, Shri. So the floor is yours.
Thank you, Ken. Yeah. First of all, thank you, all of you, for attending this FPGA roundtable, and thank you, Rohit, for a very enlightening presentation. Every time I listen to you, I learn something new. Thank you for that. Yeah. So, let's go with a little bit of introduction to what I'm going to talk about today. Yeah, the idea with FPGAs is, FPGAs are field programmable. Yeah, so they're highly configurable. Yeah, and they are the need of the hour today. Yeah. Cybersecurity is a changing field. It changes continuously depending on the kind of attacks that are happening around us, and the attacks are happening as we speak. Yeah. So you need platforms that can learn, change, and adapt in real time. As the attack is happening, you need to be able to reconfigure yourself. So FPGAs, because they are silicon, so you get the extreme hardware acceleration that you would expect from a hardware solution. Yeah. They also give you the ability to change on the fly. Yeah, so they form the bedrock of what is going to be the next generation of communication technology as well as encryption. Let's talk a little bit about Pantherun. We are an FPGA-driven company. We build everything that you would require to take an FPGA and plug it into your next communication device as the main controller. So we give you the network stacks. We give you these network stacks to build out whether you're building an edge device that's communicating over low speed throughputs on your car or in your industry. We give you also the devices that are going to take holoscan video, high throughput 4K video, do analysis of it, and then communicate it. So we give you the stacks that will allow you to scale your communication from as little as 10 megabits per second all the way to 100 plus gigabits per second. So we give you all of those stacks. We call them LITs. Yeah. We also give you encryption technology, which allows you to build industry standard encryption, AES-based encryption, PQC-based encryption. We give you all of these protocols to build your next generation product to be more secure, more resistant to attacks, and still able to change on the fly. So the power of FPGAs, I touched on it a little bit. Yeah, adaptability. They are adaptable. They're field programmable. They change. Yeah, this is chip that's not frozen in time. Yeah, it's not taped out to do one particular function. It's built into your design, so you can do one function today and you can add another function tomorrow. To give you a very basic example, yeah, you could have an FPGA built into your layer 2 switch. Yeah, you don't need a silicon, an ASIC anymore, or an SoC anymore. You could use the FPGA, build out all those layer 2 protocols to handle data that's coming in at wire speed. Yeah, 100 gigs, 400 gigs, yeah, and 800 gigs as well, as Rohit told you. Yeah, and then you suddenly decide that your application requires some layer 3 functionality. Maybe it requires some inter-VLAN routing, maybe some BGP. Yeah, you could just take that logic and load it into that FPGA on the fly, over the air, on the device while it's in the field. So that's flexibility, that's adaptability, and that's unique to an FPGA. Yeah. Rohit showed you also longevity. Yeah, longevity is a critical bedrock of FPGAs. Yeah. You get SoCs. They expire. They basically become end of life. Because the manufacturing process changes, the technology changes, maybe the functionality changes, so the SoCs become obsolete. Yeah, and you have to change your product because a new SoC will come out there. You need to redesign based on that new SoC, recertify, launch into the market. That's a 2-3 year cycle that you can avoid because FPGAs give you a 20-year life on the silicon. So you can change and update functionalities for 20 years without having to change the hardware. And of course, superior performance. SoCs, ASICs are tailored to do a lot of things. Yeah, FPGAs are tailored for performance. So you get very high throughput transceivers, which can scale. Yeah, the same device can do a whole range of throughputs. So all of this are the benefits of FPGAs. And FPGAs today, when you see them, some of them even have a processor built in. They are, they're systems on chips. Yeah, so you can decide your functionality depending on which part you want to run in hardware, accelerated. So you design Verilog or VHDL code, build your designs on the programmable side of the FPGA. There are certain things that you can run in software sequentially. You can run them off the other part of the FPGA, which is the ARM core. So gives you much greater functionality as a designer and a developer to be able to build a solution that works for you at the performance point you need, at the price points you need, with the power consumption. So you have much, much greater power over your design. So how do we enable you? Yeah. We provide you a complete range of network protocols. You can build them all into your FPGA-based design. You do not anymore need to have an ASIC that does networking functionalities. You would use your FPGA for certain functions on your application. You could also use them for networking. We give you, packet parsers. We give you a whole range of ways in which you can do MAC learning and IP learning, build out the tables within your network device, give you a whole range of protocols with over 120 different kinds of layer 2 and layer 3 and beyond protocols that we built in that you could just take and build your network device ground up. So all of this is built into our product IP that we call LITH, and it works all the way to 100 gigs. And this is very valuable in a lot of markets. We are seeing a lot of customers in different sectors start using this kind of IP along with an FPGA. Yeah, you have industrial applications, you have 5G radio, as well as the Ethernet backhaul on 5G. You have automotive systems, medical and aerospace, smart grid and energy, defense. The applications and the use cases are extensive, and this kind of a solution lends itself to most of them. And why is this happening? Why is this change happening? It's happening because SoCs or ASICs that you see out there, they are becoming end of life. The opening is there now. Build something that is non-obsolescent. Your next design should be FPGA based. You should take advantage of the much longer life, much greater performance, much greater flexibility that's available to you. So when we built this whole stack, what we realized is that we can give you a huge level of functionality benefit. As we do the stack, we also build encryption on it. We're offering IPs which are AES or which are PQC. You could either use those IPs of ours, or you could use the ones that AMD hardens on its FPGAs as well. And you could have inline encrypted communication. So imagine that your next networking device, you wouldn't need to have an external encryptor to protect the data. You could have it all inside your own next networking device. So that's the functionality that we can give you with all the IPs that we give you, all the designs that we can give you. So you have inline encryption, and encryption is the need of the hour today. You're seeing, acts like the Cyber Resilience Act that's getting enforced in Europe. You're seeing, the post-quantum cryptography being a mandatory requirement in North America. You're seeing such laws being passed in India, in China, and the rest of the world as data protection becomes important. So building out a configurable solution on an FPGA with IPs that we can provide you, give you that much greater flexibility. And our IPs are extensively tested for nanosecond performance, for 5 years MTBF. So this is extensive technology that's available to you to build your next 100 gig or lower or higher network device with an FPGA. So let's talk about encryption in a little greater detail. We've also got very unique encryption technology. AES, I think a lot of you will have encountered it, have worked with it. It's available on our laptops as TLS. It's available on our routers as IPsec. AES requires a key to be exchanged. Yeah, we've built a version of AES where you don't need to exchange the key. What is the benefit? When you exchange keys, I mean, these keys can be tapped. Yeah, they add vulnerability to the encryption because from that key you can try and find a way to reverse engineer the encryption. It's also expected that quantum computers will be able to break AES in a matter of a few seconds when they see the key exchange. Yeah. So all of this, I mean, as you see laws being passed to implement PQC, the reason is people understand the threat that quantum computers provide. And with our stealth AES concept, you do not need complex PQC algorithms. The key exchange is eliminated. Yeah, a key is generated dynamically to encrypt data. Key is generated dynamically to decrypt data. No need for a key exchange. So this is also available to you as part of FPGA IP. Yeah, and it provides significant benefits over all the typical AES implementations that you see. It works across layers because it doesn't change data format. It doesn't require a key exchange. It's ultra low latency. In fact, we have only hardware latency as we implement our stealth AES up to 100 gigs. So you have very, very high performance for your edge device and your edge data center device. And we have a lot of real world deployments. I mean, Rohit touched on railway. We've got devices that are in the field working in industrial applications, in railway applications, in military applications as well. And we provide all of this technology along with hardware. So you don't have to look at a very, very long, complex life development cycle. We can give you designs that would take an FPGA, build out your next network device along with our IP built in. And we've got significant level of validation. We've extensively peer reviewed. We have been validated by NIST. We are in the course of the 62443 certification as well. So this is technology that's gone through a lot of evaluation, a lot of customer as well as certification body evaluation. And the idea is, I mean, what we can give you today with AMD, I mean, is a comprehensive solution that takes you to build secure networks secured by ES, secured by PQC, up to speeds of 100 gigs. Yeah, so all the way from your lowest end edge device all the way to the edge data center. And the next generation, I mean, as we all scale together, I mean, we go to 400 gigs and beyond as well. And we have extensive hardware that we can support you with. We've got, I mean, a switch hardware that we can give you at 10 gigs, 100 gigs. We can give you SFP-based encryption devices. We can give you PCIe-based encryption devices as well. So a wide range of hardware that you can take and build out your next generation offerings. And we also expand into various other kinds of protocols. MPLS is another standard that we're building out on FPGAs. TSN is an up and coming industrial standard. Industrial protocols like Profinet, Ethernet IP, and so on. All of these are available for real-time performance. And encryption as well. I mean, when you look at encryption, we've got AES, GCM implementations. We go all the way up to 512-bit keys on AES. We've got our key management integrated with GCM. We've got PQC algorithms like Crystal's Dilithium and Sphinx Plus already implemented. Crystal's Kyber is also in the works. Yeah, we have also, I mean, when you look at an FPGA-based device, you're looking at over-the-field updates. We've got software that allows you to do OTA updates across your devices. So look at us as a complete offering end-to-end. that can help you use FPGAs in more of your networking applications. And the idea for us is to provide IP, provide handholding, provide support, provide hardware capability to allow you to transition into a more secure, more long-lasting future built on FPGAs. And we're global, so we're available to support you globally. I mean, we've a significant presence in India, in Asia, in Taiwan, yeah, all over Europe, where we have significant engineering and support available, also in North America. So this is I'm available here. Looking forward to answering your questions along with Rohit and Ken. Yeah. Thank you so much.
All right. Thank you so much, Rohit and Shri. There's a ton in there. And we've got a bunch of time now to do some discussion and some Q&A. We've already had some questions come in from the folks attending here today, and keep those questions coming in, folks, because we want you to be part of this discussion too. So we're just gonna, I think, jump right in here. Rohit, feel free to join us here on camera as we get into our Q&A discussion and our roundtable here. Now, I want to start pretty high level, and the sort of biggest question when we're talking about FPGA versus other sort of IP, traditional CPU software centric approaches. Can FPGA-based security architectures compete and even outperform those other sort of methods at really high throughputs? Because of course, traditional thinking would be, well, you need a bigger processor, you need to push more power and stuff through to do these, high throughput applications for security. So are FPGAs better at those levels? And I think I know what your answers will be for that, but why? Why are they better there? And why don't you take the first swing, Shri?
Let me answer it less like an FPGA person, more like a developer. Yeah, I've built ASIC-based solutions for bulk of my life. I mean, my previous company, we built, one of the switches from one of the largest ASIC makers. It's very easy to see that FPGAs outperform them in communication. The transceiver quality, the way in which the kind of throughputs you can achieve. We are able to quite comfortably at very, very high volume of traffic get an 8-10% improvement in throughput. That's significant when you look at you're looking at hundreds of gigabits of data per second passing through these ports. That's a significant amount of throughput benefit. So as a developer, no doubt at all. The FPGAs just give you that much more performance.
Yeah. What about from you, Rohit, on the AMD side? I think that you'll probably agree that FPGAs can handle this, but what about them makes them sort of uniquely suited to these high throughput situations?
Yeah, I think I'll resonate with what Srini mentioned. Just to give a context, AMD has multiple compute engines, right? We are CPU, GPU, adaptive SoCs, and FPGAs. So no offense to CPUs, it's a very large part of our business, but this kind of application do require very low latency, very high throughput, and also whatever we have been talking about, the hardware accelerated trust, like hardware security features, which is way beyond what a CPU can support, and the longevity, right? All these features make applications of this type more suitable for FPGA rather than fixed architecture like ASIC or a CPU. That's my take, Ken.
Yeah, absolutely.
Maybe Ken, if you don't mind, maybe I add something to what Rohit said. Yeah.
Of course.
See, when you look at encryption itself, yeah, I mean, there are two parts to encryption. One is the encryption, which is AES, yeah, or could be something else. Yeah. Now, AMD gives you the AES acceleration. Yeah. So you are getting the high performance, high throughput hardware acceleration for encryption. Yeah. Other CPUs also do that. Yeah, no doubt. Yeah, the acceleration exists on them as well, and you can utilize them. Yeah, but I mean, what the other CPUs will do is they will tell you that generate your keys using software. Yeah, yeah, and then feed the key into our AES accelerator, and then you get encrypted data. Now,
Yep.
that's a problem. I mean, it's a security problem as well because I mean, anything that you feed into RAM or DDR, yeah, which is what a CPU runs off, okay, is subjected to a runtime attack. So these are sophisticated attacks, but they can happen. Yeah. So in which case your key can be compromised. Yeah. Whereas now, if you use FPGA ground up for your whole encryption implementation, yeah, you will be able to also do the key generation on the FPGA. Yeah, you don't need to use a software process, a sequential process for key generation. You just have one block that generates the key. Yeah, that block can store the key in secure storage that's available on the FPGA. Yeah, and reuse that without ever entering a memory. Yeah. So another very significant benefit of doing this all in hardware.
Yeah, absolutely. That makes a ton of sense. Thank you for adding that in. I want to jump straight to one of our audience questions here, because I think it's relevant to what we've just been talking about. Um, Ashif wrote in that hardware-based security is generally considered to have reduced attack surface due to its fixed implementation. Um, Given that FPGAs are reconfigurable, which we generally see as an advantage, and they can support mutable hardware designs, how do FPGA-based security architectures justify the claim of having a smaller attack surface than a traditional hardware fixed implementation? Rohit, why don't you go first on this one?
Yeah, sure. Thank you. Thanks for the question. When we say the reconfiguration or reconfigurable hardware, it doesn't mean that it is open surface or it has a much wider surface of attack, right? First of all, when you look at this kind the devices, if you went through my session, I actually talked about several security features that are built into the device. These are, for example, the hardware root of trust, the secure boot that we talked about, several cryptographic features that are silicon level features that are built in, and also on top of it, you have the design methodologies, right, where you can actually separate the configuration and the data planes through the isolation design flow, so that you do not give the opportunity for the attacker to access the data plane, even if he gets access to the control plane. Now, these are all certain advantages that you have. Now, while the device itself is reprogrammable, that is the advantage that it provides are things like what Srini mentioned. You can change the persona, you will have longer life cycle of the devices because it's a programmable hardware. Longevity improves, field programmability improves, field repairability improves, and runtime immutability if you require some sort of a reconfiguration. Those are the advantages of programmable hardware that in no way reduces uh, the the security features or increases the risk of the attack surface in the device, right? That would be my input.
What about you, Shri?
Honestly, Rohit covered everything technically that's possible to cover there. I think it was it's something I learned from as well all the time with Rohit. I think I said that the second time already here. Yeah, but what I'll do is then let me go the other direction then. Yeah. Now FPGA makes the developer have greater control. Yeah, so I mean, you can, I mean, you can increase the attack surface because it's configurable. Yeah, but because it's configurable, you also can reduce the attack surface. Yeah, you have the control to do that. Yeah, if I use an ASIC today, I mean, there are a lot of areas within the ASIC that are just black boxes to us. Yeah,
Right.
yeah, they
Yeah.
they share a lot of information with us. I mean, there's no doubt at all. I mean, everything is not wrong with them. Yeah, they do share information, but they also have places that I mean, they have developed, they have outsourced development. I mean, their SDKs sometimes are locked and things like that. So you don't know. Yeah, you don't know what you're working with. Yeah.
Mhm.
Whereas when you have configurability, yes, the responsibility lies more with you, but then you have the ability to implement that responsibility. So that's
Yeah.
that's how I would say FPGAs are better.
Yeah, I think Srini, thanks. Gave some more ideas for me, right? When you look at the CPUs, right, or let me not just categorize CPUs. If you look at CPUs or any other ASSPs or ASIC, which runs on certain OS with some firmware and some application, that is the one which adds up to your attack surface, right? Because, like Srini mentioned, many of those things are not in your control. So here is a hardware where there is no OS, there is no shared address space between multiple processors. There's no interpreter that you require, so it kind of reduces the overall risk, um, depending on how you design the device, how you design use the device to do the design, right? And that's exactly what Pantherun is doing, right? They have 100% control over the FPGA, right? What we're providing is literally like a blank sheet of paper, and they have full control over the FPGA, so they can ensure that all the loopholes are fully covered with the application that they're building in.
Yeah, absolutely. The, I think that like the flexibility, as is almost always the case with FPGA, is an advantage here. Not only can you, as Shri was saying, expand and retract the attack surface. I don't know why you'd expand it, but maybe there's a case. um, but you can also uh, it can be flexible as new vulnerabilities emerge, or you discover a bug, for instance, or even new attack vectors that hadn't been invented yet when you first deployed the device, right? So it allows you to be more flexible and more modular over time too, right? Um,
Correct.
let's keep going on the audience questions here, because this one's sort of about the market space in general. Uh, they want to know how the industry in general is embracing FPGA-based mutable designs for safety critical systems. How are these designs satisfying certification requirements in, they asked about specifically like highly regulated areas like automotive or rail. And, I know that FPGAs are coming to play in aerospace and defense as well. But there are certification requirements and safety requirements across a lot of different industries. So I'll broaden that even further and just sort of say, how are FPGAs meeting those certification requirements? We've
Yeah.
seen a ton of industry adoption, but are we seeing certain industries be slower or quicker? Just sort of love to see what you guys are seeing
Sure.
out there. Shri, why don't you go first this time?
The way I see it is, I mean, industries are tending to have, either they comply with certain certifications that are generic, There's country-specific certifications or region-specific certifications. There's 62443. There's, of course, the FIPS-related certifications. There's common criteria. So there are different countries have certain certification needs. Yeah, I think on the FPGA, they're going through extensive validation. Yeah, across these industries, you see, Rohit mentioned they have a security working group, yeah, which is specific to the Xilinx range of FPGAs. Yeah, so AMD is looking at it by device. Yeah, and they go through the certifications, they go through the laws and the rulings that are happening. The direction that PQC is taking, yeah, the standards that are coming out today. Honestly, a lot of the PQC standards are not really set in stone. They are still moving targets. Yeah, but I see AMD keeping up with those moving targets, offering them in certain revisions of their silicon. Yeah, and then I feel, in that sense, they are keeping up, and they're actually exceeding in a lot of cases the efforts from the silicon makers. So that would be my view. And then solution providers like us have to also do that, because ultimately you don't just certify the FPGA, you certify the solution, you certify the product. Yeah, having the device certified from AMD takes it some way, but then ultimately what you build has to also go through certification.
Well, there's several layers involved with any final device, as always. Rohit, what about you? Have you been seeing this adoption and this sort of certification be a struggle, be pretty easy? Oh, Rohit, I don't have your audio.
My bad, I was on mute. I would like to answer this one in detail, right? So the question was related to the safety critical system. So when we talk about safety, right, we are specifically talking about the functional safety. Now there are two pieces to this. One is the device meeting any certifications, safety certifications that are approved by the, let's say, various bodies. And then what about the software on top, right? Like if I'm using certain software tools to generate software, then how about the software certification for those? Now there are two types of application that is mentioned by the audience here. I think Ashif, you have talked about railway and automotive. Now both have different set of certifications, right? When you look at railway, you are looking at IEC 61508, at least at a global level. Like Shini mentioned, there are also country specific safety certifications that goes in. Like if you take specifically India, there are few more bodies who certify the functional safety for railway. And the automotive, we have a standard called ISO 26262, right? These are the two main certifications that you can see. And the key thing is both these standards we meet with our silicon features. Like we have the silicon which is actually certified by industry standard like TUV. Predominantly TUV is the one we use, but TUV has TUV and also Exida. These are the certifying bodies. They have actually certified these silicon to certain standards. Like for example, if you take our zinc ultra scale plus MP SoC, 60 nanometer SoC, which is what Pantherun also uses for some of the application, these are like SIL 3 certified as per the IEC 61508, and also as per ISO 26262, it is SLC certified, right? It's not SLD, it is up to SLC. But it doesn't stop there with the silicon. It also carries on, like if you're using our Vitis tools, like Vitis and Vivado tools. Now we also get that certified, right? Like Vitis is certified by TUV for 61508 26262. Same with Vivado is certified. So So any IP development that you do on top of Vitis and Vivado are also naturally kind of pre-certified to these standards. But at the end of the day, finally you need to get your system certified. That stays with your hands. But majority of the underlying technology is pre-certified for these standards. Ken.
Yeah, absolutely. And unfortunately, I think I'm going to have to bring us to a close with that. But I think we ended on a really important area. So thanks to both of you. Folks out there, that is the end of our time, unfortunately. If we didn't get to your question, there was so much to talk about on these topics, so I'm sure we didn't. One of the folks from Pantherun will be in touch as soon as they can to get you an answer. Remember, you will receive a link to the archive of this presentation and discussion, so you'll be able to check it out again later. I'd like to thank Shri and Rohit for the great discussion, and thanks to Pantherun for sponsoring this event. Of course, none of these events or discussions would be possible without you out there, the engineers and developers working hard to build this embedded industry that we're all working on together. Thank you all so much for attending, and have a great day.